Hey everyone. I know a lot of you are expecting me to make Advent of Code videos every year, and it's been really fun to do that. But I wanted to make this video because, it's reasonable to think there's going to be a day where I just don't have the energy to do it anymore. I recently got married. I turned 30. Um, there's a lot of stuff going on in my life, and on that day, people might ask themselves, like, was it something we said? Was it something we did? Um, but that's not this day because today we are doing Advent of Code Day 1. Welcome back. I am very excited to get started. I haven't looked at the problems. For those of you who are new to these videos, every year, for some reason, I decide I'm going to torture myself with 1 to 25 Advent of Code problems. We usually make it about a week before we give up. But every year we do it in my favorite language, Elm. So over here I've got Ellie. This is kind of like the code pen for Elm. It allows me to write stuff on the left and then compile it on the right. And so how I'm going to work through these is I'm just going to take the problem input that we're going to get, and then one step at a time we're going to use Elm's pipelines to transform that input from the initial problem to the answer. And then we're going to plug that answer in and it's going to work. So if you want to follow along, you can go to ellieapp.com. I'm going to have a starting template in the description. So if you want to try day one's problem without me, go ahead and do that. But I'm just going to dive right in. I have not seen the problem. I have logged in, but we're going to click on this and we're just going to go through it together. No edits, no cheating. Let's see how it goes. All right, day one, historian hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figure out the chief historian must be in one of the first 50 places they'll look, so in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. So we're going to collect stars by solving puzzles. We're going to get 2 puzzles made available each day, and the second puzzle will be unlocked when we complete the first. And so each puzzle grants 1 star. Good luck. All right, so you haven't left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. Seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups. They are each searching the office, trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, which is our puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. So here's an example. We have 3, 4, 4, 3, all that stuff. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and the second smallest left, second smallest right, and so on. Within each pair, figure out how far apart the 2 numbers are. You need to add up all those distances. For example, if you pair up a 3 from the left with a 7, the distance is 4. If you pair up a 9 with a 3, it's 6. So the order doesn't seem to matter. So it looks like, for this example, let's copy this in our clipboard here. What they're saying is that the 1 is the smallest and the 3 is the smallest, so we're going to pair those up, and that gives us a distance of 2. And then we're going to work our way through these lists. So when we do that, we're going to have all these distances at the end, and we're just going to add them all up. And so for this practice input, the answer should be 11. And then we're going to get our own puzzle input. So when I click here, this is my input. It's huge numbers. It's going to be different than yours. So my answer is not going to be the same as yours. But the code that we write should work for anyone's input. So how I like to start these is I like to copy this in. And then I like to use multi-line strings. Let me get rid of all these silly comments that I added. Yeah, the way I like to get started is I make a nice multi-line string. I just paste in that input, If I hit compile, you're going to notice that I'm going to have like these new lines in front of the 3. That's because there's a character in between these cursors. So what I like to do is I like to do string.trim. And what that's going to do is that is going to cut off the white space after, it's going to cut off the white space before. So we should see this string get a little bit cleaned up. We're still going to have new lines in between each line, which is totally fine. It's actually something we want. So over the course of this video, I'm just going to be transforming this input one step at a time and walking you through the different core Elm like functions and stuff that I'm going to use. So here is the Elm core library. This is available at package.elmlang.org. I'm using a special URL here. If you have really good vision, this says dark.elm.dmy.fr. This is just a dark mode friendly package explorer. When you're making YouTube videos, it's nice not to blind people. So that's why I'm using this one. But you can go to elmlang.org and see all these docs for yourself. So for example, I just use the trim function. That is available here. If I search over here, I can see trim basically gets rid of the white space on both sides of a string. So we're going to be using little functions like that, one step at a time. The next function I'm going to use is string lines. So this is going to break apart this single string into a list of strings so that each line kind of gets its own entry. You'll see that 3, 4, 4, 3, these are all separated by commas now because they are in an Elm list. What that's going to allow me to do is it's also going to allow me to list.map and try to take these numbers. Right now they're text, they're string values. I need to split them on space so that I can get at like the integer values, so I can start adding them up and doing math with them. We're going to need to do that in order to compare, like, is 1 less than 9, that kind of thing. I think we might be able to compare strings, but it's not gonna, I don't know if that's gonna work so well. So let's not do it that way. So what I'm gonna do is each line one at a time, I am going to make a little inline function here, and then we're gonna pull it out into its own function. Why don't I actually do that right away? List.map, I'm gonna say 2 pair of numbers. So what I'm doing here is just like I said, main equals. This is like the function that runs when our program starts. I'm going to say to pair of numbers, it's going to take in a line. And what we're going to do is we are going to kind of transform that line over time. So if I run this, the output's going to be the same. But what we can do is we can say, split on spaces. Or we can say string.words. This is a built-in core library thing. It comes from Elm that's going to basically split 3 and 4 so that they get their own specific entries. What I want to do is I want to say, take those words, and then why don't we turn those strings to integers? So for each word, we're going to go through that list. We're going to go through 3, we're going to go through 4, and we are going to run this string.toInt function. This is when things are going to start to get weird. We're going to start to encounter some of Elm's quirks. So not every string is a valid integer. You see all these just things? If one of these inputs was invalid, Elm wouldn't be able to turn that into a valid int. So the string.toInt function that comes with Elm, it doesn't return an integer, it returns a maybe integer. So what that means is it can still return a value, it's not going to crash, it's not going to do anything crazy, but there's going to be certain things that just aren't going to work, and it's going to be up to our program to be able to filter out those cases or handle them. So the way I'm going to handle this, I'm going to put 4 right back where it was. I'm going to use list.filterMap. And what filterMap does is, if we look at the docs for filterMap, is it allows you to basically run a function like toInt, and it's just going to get rid of all the justs in the front. See all these justs? It's only going to keep values that have the just prefix. And so we're going to go back to what we had before, which was just numbers. So notice the quotes are gone. We've done it. We've turned these this single string into a list of integers. And what I'm going to do is I'm going to turn this into a pair. Basically, what we want is we want this list of integers and we want this list of integers to be separate. So now that we have a list of lists of integers, we got to try to find a way to kind of match these up pair by pair. So I need to think about this. How are we going to do that? How are we going to make that work? So something that helps me in Elm is whenever I make a function, these are always optional, these type annotations, but I like to annotate what I expect the input to be and what I expect the output to be. This is an Elm type annotation. Just like TypeScript, it allows us to annotate what we expect our program to return. So for example, this returns HTML, and it doesn't really send any messages. HTML is something that is available from the HTML package, but by annotating these options or annotating these functions, we're able to make sure that things behave as we expect. So what I want to do next, I think, is I want to basically group all these together. So if I can get a list of just like the first values and then a list of just the second values, I think we're going to be in good shape. How am I gonna do that? Let me think. Maybe I can use a list.map and just list.head all these values. So I'm gonna get rid of the annotation for a second because it's not gonna be the same when we're done. If I do list.map, list.head, what this should give me is 3, 4, 2, 1, 3, 3. But with the justs around them, I think. So list.map. Oh, I need to do a list.map of this entire list. So we're kind of like, we're in weird meta territory here. Oops, do something wrong. List.map, list.head. Oh, maybe I just need a list.head. Sorry, I don't need a map. Okay, here we go. 3, 4, 2, 1, 3, 3. So what we're seeing is 3, 4, 2, 1, 3, 3. This would get me the first pair of numbers. What I want is I want the first pair, I want the second pair, and then yeah, I think what I want to do here is I want to return 2 lists. So my goal is going to be, I'm going to have the first list and the second list get returned. I'm going to return both of those, so I'm going to wrap these in a parentheses to say this is going to be a pair of values. So this is going to be the list of its number of pairs. So I'm going to make a little local variable, just like you'd say x equals 3 in another language. What I'm going to do is I'm going to say let list of number pairs equals this like intermediate value that we have. So if I do this, this should be a list of integers. And that's right, I'm always returning empty list here. So what I want to do, I think I'm getting ahead of myself. Let's just stop with this and let's build a function on the outside here. So I'm going to hit this format button. This is going to snap everything into place for me using Elm format. So this is where we are. Let's pick up where we left off with a new function. So after we run this, we're going to transform this whole list into a two lists of ints. We're going to make our own function. 2 lists of ints. It's going to take a single list where we have a list of integers as each entry. So this is our list. This is our list of lists. And what we want to do actually is we want to return basically 2 separate lists. We want to basically extract out all these values like we saw when we did list head. So list of lists comes in. Let's do list of lists comes out, and I'm just going to comment this out so we don't get any errors because we don't have this return type yet, so we don't want to get any Elm compiler errors for doing that wrong. Cool. So what I'm going to do is I'm going to say let's say the first thing we're going to return. So if we did this, what we would end up doing is kind of duplicating our value and having 2 pairs. So I'm going to operate on this first pair, and I'm going to say list dot map, and then what that's going to do is that's going to run a function on each of these. I'm going to say list dot head. So if I do this, I'm going to get my just 3, just 4, just 2, just 1, just 3, just 3, that kind of thing. And that's the left side. So this is the left. Notice I have all those justs, and we learned a trick earlier to get rid of those. we're going to do that filter map. That is going to make it so that I have 3, 4, 2, 1, 3, 3, 3, 4, 2, 1, 3, 3. We're doing good here. So we're just going to do the same exact trick here. It's almost like this, but what we're going to want to do before we call filter map is we are going to drop the first element. So if we do list.drop1, what that's going to do is that is going to get rid of all of the first elements in the pair. So if we're doing this one step at a time, notice that when we called list.drop1, so initially we had this, right? What we're going to do is we're just going to drop all the first numbers by calling list.drop1 on each of these inner lists. So 4, 3, 5, 3, 9, 3, and that matches what we want on the right side, but we don't want it to be wrapped in the square brackets. We just want the first value in each of those lists. So by the end, we have our numbers ready to go. So now we're ready to add this annotation because we are returning a pair of two lists. So that's the current value that we have. So what I'm going to do next is I am going to sort each of these lists. So if I call this.sort, what it's going to do is that's going to sort this first list from low to high. So here now it's 1, 2, 3, 3, 3, 4, and I'm going to do the exact same thing to the next list. And so now these are each sorted. So now that I have each of these individual things, I can pair them up. So let's pair them up. We'll make a function called pair them up that takes in what we returned last time, which was kind of like a left list and a right list. And it gives us a single list of pairs. And that's going to allow us to kind of group these together and then get the difference. So I'm going to call the one on the left list, and the one on the right list. What we're going to do is we are going to say list.map2, and that's going to allow us to loop through both of these lists at the same time together. So list.map2 is going to take in the left number and the right number, and it's going to allow us to basically pair them together. So we can say, like, 1 and 3 are going to be put in a pair. So the left num and the right num are going to go together. And so by the end, we're going to have 1 and 3, 2 and 3, 3 and 3, 3 and 4. And if we go back to the problem, those are the pairs they talked about. 1 and 3, 2 and 3, 3 and 3, 3 and 4. We've done that first step. All we need to do now is, now that we have a list of pairs, we want to find the differences between those numbers. So now that we have a list of pairs, it's really easy to find the difference by getting like the kind of the absolute value of left num minus right num. So we can do that all in one line if we want. We can kind of make this whole thing return the difference, in which case I think I'm going to rename this to get difference. Actually, you know what? Let's keep this function simple, and we're just going to list.map the difference. And what that's going to do is that is going to take each of these pairs one at a time and allow us to figure out what the difference is. So this is one function that's going to perform the logic that the problem described, where we kind of have like the left and the right. We want to say, what is the left minus the right? But give me the absolute value of that. So ABS is a part of the basic like math stuff that comes with Elm. So just like minus, we're going to be able to take negative numbers and just make sure they're always positive. So that's what that's going to do. So if I do this, we should see 2, 1, 0, 1, 2, and 5. And this is one of my favorite functions in Elm, list.sum. This is going to take all these numbers in the list, add them up. We get 11, which is great news because that is the number we're looking for. So it looks like our algorithm at least works on this input. I'm going to save this right here as we have it. And then I'm going to copy that in my clipboard, and I'm just going to open up a notepad. And yeah, we'll do that. So this is going to be, for the video, we've got LEF. This is going to be part 1 with puzzle input. Cool. So what I'm going to do is I'm going to take my puzzle input, I'm going to copy that in, I'm going to paste this in and see if we get a number. we get a huge number. So when we do the differences between all of these after they're sorted, we get this number in the 2 millions. So what I'm going to do is I'm going to plug that in here. And we did it. We got a gold star. So that's good news. So we're one step closer. So normally part 2 kind of adds like a twist to it. And it's gonna we're gonna see what the kind of the new challenge is that builds on top of this problem. All right, part 2. Your analysis only confirmed what everyone feared. The 2 lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting, but in the commotion they notice an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each time the number in the left list after multiplying it by the number of times that it appears in the right. Okay, so basically take 3, how many times does it appear in the right? So 3 times 3 is 9. It appears in the right list 3 times. Got it. So 1, 2, 3 is 9. Second number is 4. It appears once, right? So we get 4 times 1. 2 doesn't appear at all in the left list. So because it doesn't appear at all in the right list, we're just going to get a value of 0. And the fourth number 1 also does not appear in the right list. So that's 0. 3, again, we're going to do 9, 9. So when we add up all those numbers for our puzzle input, we're going to get 31. So what I'm going to do is I'm going to undo this, see if we're back at 11. Great. I'm going to change the name of this to part 2. And I'm going to save this. Awesome. All right, so we need to modify our code. At some point, we went kind of too far. And so what we can do is we can use comments to work our way backwards to the last place that might be useful here. So pair them up, I think, is too far. Here we had 2 lists, and I don't think the order matters here. So maybe sorting isn't needed anymore. But this is kind of where we can reuse our code and where we can kind of pivot to solve the other problem and modify it. So by using these pipelines, it's really easy to just kind of like work your way backwards. So I'm just going to delete this, and I'm going to delete the sorting too. And what we're going to do is we are going to find the number of occurrences for each number in the right list. And hopefully that can just be like a lookup where we can loop through the list. We can kind of tally up how many times we see a number. And then our algorithm that we're going to write, our little formula that we're going to write, is going to work its way left to right through the first list and just kind of do the value times whatever like count we found here. So I'm going to import a new data structure called dictionary. And what that's going to do is that's going to allow me to create values that map like the number 4 to how many times it showed up. So that would map 4 to 1, it would map 3 to 3, because there's 3 of them, map 5 to 1, 9 to 1, etc. So let's see if we can do that. So I got these 2 lists of ints. What I'm going to do is I'm going to say tuple.mapSecond. A tuple is a pair in Elm. So when we talk about tuples, when we spell it right at least, let's do map second. What you can do with tuples is you can talk about pairs. You can call functions like first, that'll just give you the first part. Second will just give you the second member. So here are some examples. This just gives you the 4. If you give it John Doe, it'll just give you the Doe. What you can do is you can say map second. So what map second does is it says, I just want to transform like the right side of this pair. I don't care about like the left input. So here we're taking the square root of the second part of this tuple. So what we're saying is leave stressed alone, return that as is, but do the square root of 16. Or leave stressed alone and just run negate on 16. So what we're doing here is we're saying we've got this list, or we got this pair of list int, list int. I just want to run some code on the right side so I can turn this list of integers into what I'm going to call a count lookup. So I'm going to keep this up here just so we can kind of talk about it. It's going to take in our list of integers, right? And it's going to say how many times does the integer, like 4, 3, or 5, how many times does that show up in our list. So this is going to be our list. We're going to have basically a dictionary that comes out the other side. So if we had our list and everything showed up once, what we would end up spitting out, it would be something like this. We would take each number and we'd say each number appears one time, and then we can turn that into a dictionary. And what that would allow us to do is when we plug in 3, it's going to spit out 1. When we plug in 4, it's going to spit out 1. And so all these numbers are returning 1. So that's kind of silly, but that's where we're at. What I need to do is I need to work my way left to right. Let me comment this out. I want to work my way left to right and just kind of keep a little tally each time we see a number. What does that look like? So I'm going to use a fold L. And what a fold L does is it takes in each number one at a time and it builds up like some data structure. So I'm going to call this counts. And initially, counts is going to be like an empty list. So what this is going to do is if I run this code, it's going to call this function over and over again. Let's give it a name. Let's say add to counts. Add to counts. This is going to take in a number. It's going to take in a dictionary. And it's basically going to add that number to our running total. So this is our count lookup here. What this code's doing is it's never updating the dictionary. So the empty kind of starting value that I give to list.fold never gets updated, it always gets returned. But what you can imagine is I might do a dict.update. So let's take a look at how that works. Maybe I want to update that dictionary. So I can update at a certain value. I'm going to run a function, and then I'm going to take in the existing dictionary and return the new dictionary. So let's try that out. Let's kind of define this maybe int to int function together. So the key that I'm interested in adding things to is the number that I'm talking about. So maybe that's like 4 the first time it comes in, then it'll be 3, then it'll be 5, then it'll be 3, that kind of thing. And what I want to do is I want to take in kind of the count so far. Let's call it that, count so far, for that number. So how many 4s have I seen so far as I'm running through this program? What I need to do is I need to return the new value. So if this is the first time I'm ever seeing a 4, I'm going to get a nothing value. So I have no count. So what I want to do is I want to return 1, and I want to say this. Let's comment this out. Let me comment this out too, just so we can get back to when the output on the right was easy to talk about. All right, cool. Let's go right back to where we were. So list.fold is going to work through these numbers one at a time. It's going to start with 4. So initially we're going to have an empty dictionary, and we are going to be looking at the number 4. And we're going to say, hey, let's update the entry for 4. And so this is kind of like how many 4s we've seen. And since we just started running this like loop, we've seen no 4s. So we're going to hit this nothing branch, and we're going to say, hey, this is my first 4. Give it, let's insert a value here. Let's put in 1. So when I return just 1, we're saying like set something in the dictionary to 1. And then when I'm saying just existing count, what this is saying is like, let's say we go through, we say just 1 for 4, we say just 1 for 3, just 1 for 5. But when we hit this 3, we've already inserted a 1 for 3. So this is going to be just 1 because that's what we returned a little bit ago. So what we want to do is we want to increment that count. So this is a way of working through a loop. And hopefully by the end of this, we're going to end up with our counts. I know that was like a lot to take in all at once, but if we add our annotations back and I format this, I think this will just work TM. So what we end up with is if you give me a number like 3, I'll tell you that there are 3 of them. If you give me a number like 4, I'll tell you that I found 1 of them. If you give me a number 5, I've only found 1 of them. You give me a number 9, I found 1 of them. So we're in a really good place. What we're able to do now is we are able to get the similarity score. And how the similarity score works is we are going to take in this weird pair thing that we made, right? We ended up with a pair where the left side is a list of integers, and the right side is this count lookup. What we need is we need to basically get the similarity score for each of them. So I'm just going to do that as a list of ints for now. I'm going to comment this out. But what we want is we have our left list, and then we've got our lookup. I'm going to call it the right lookup. Or the cookup. That sounds fun. And we're going to do the exact same thing. We're going to work... actually, we're going to do a list.map for this. We're going to say this is our left list. And we're going to do list.map, and we're going to say get the similarity score. So 2 similarity score. And we're going to give it the right lookup. So we're going to pass that in. Let's make this a local function here. So 2 similarity score. It's going to take one number at a time from our left list. It's going to take 3, it's going to take 4, it's going to take 2. It's going to try to do a lookup over here. And if it gets a value back, it's going to return what the count was times the value. So this is going to be our number from our left list. So I'm just going to call that left num, so it's easy to think about. What we're going to do is we're going to say, in the case where I look in my dictionary, I try to get that left num from my right lookup, or from my counts. Let me call this counts. I try to look, I'm going to check that back, sorry. I'm going to try to see if I can find any, like, let's say any 3s here. So if I look up 3, I should get a 3. And so this is going to be how many times it shows up. So if I do left num times that count, that'll give me the similarity score. But if I do nothing, this means that I didn't find a thing. So for example, 2, if I try to find the 2 entry here, I'm going to get nothing back. There's no entry that's 2. So that I'm just going to return 0. So by the end of this, oops, I couldn't spell 2 similarity score. Oh, there we go. I just forgot the word score. By the end of this, we get 940099. Does that look familiar? That's exactly the numbers that we need to add up, 940099. So we get to do my favorite part of these problems, list.sum. And hopefully that gives us that 31 that we're looking for, and it does. So what I'm going to do is I'm going to add back in this annotation. I'm going to format, compile, so it still works, and we're going to save this. And I'm just going to keep this in my clipboard here. Awesome. So that is the solution for the practice problem. Let's get my puzzle input, which hasn't changed. Let's just take this puzzle input, and let's see if we get the answer we're looking for. We get a number that's much bigger. It looks like it's 22 million instead of 2 million. Let's see if this is right. And it is. We did it. Okay, that was a longer day one than I expected. There was a lot of list looping, a lot of folding. What I'm going to do is I'm going to update the links in the description to include our answers, so you can play around with these. Let me know how that went, if that was confusing, if there's any more clarity. Also, something to know is I have a free 40-part Elm tutorial course called Welcome to Elm. I'll also drop that in the description. So if any of this went over your head, if you're feeling like, oh, I didn't get it, we cover all of these basic modules, lists, dictionaries, strings, much slower pace, 5-10 minute videos. So those might be helpful if you're following along and you don't want to be confused. But yeah, thanks for watching, and I'll catch you later, maybe for day 2.